Hi everyone. So today here is we are going to cover power rule and chain rule. So let me summarize what I gave you in last classes here. What I gave you so far related to the derivative last times, right? Last classes here, last time. I gave you shortcut formula. What is shortcut formula? That is what sometimes you call a shortcut formula. What is that? If you have f of x equal x to the power n, then the derivative of this, it will be nxn minus 1, right? That is shortcut formula. That's what I gave you. I gave you also product rule. What is product rule here? Product rule here, if you have f of x multiplied by g of x, they have a product, then the derivative of this, it will be f g prime plus f prime g. I give you some example related to this, and also I give you quotient rule. What is quotient rule here? Quotient rule, if you have a fraction f of x divided by g of x prime, what is the derivative of this? It will be g square g f prime minus f g prime. G square g f prime minus f g prime. Okay, so that is it's called quotient rule. So if I give you one example here, f of x, if I give you one, if you have say y equal here x square minus or x cubed minus 3x to the power 2 to the power 2. What this bracket means? The bracket means here, what is the question here? They ask you to find y prime. I need to get y prime, or sometimes we have to find dy by dx. How to get y prime or dy by dx? This one, it's a bracket multiplied by itself how many times? 2 times. X squared minus 3x multiply, that's a cube here, x cubed minus 3x, x cubed minus 3x. So it's a bracket multiplied by itself how many times? 2 times, twice. Then you could apply product rule here, where that is your f, that is your g. I need to get y prime, so it will be f g prime plus f prime g. So what is your f? The first one, x cubed minus 3x. G prime, which is x cubed minus 3x prime, plus f prime, which is x cubed minus 3x prime, multiplied by g, which is x cubed minus 3x, right? So I'm just applying product rule here, and then just go ahead and take the derivative. You don't need to simplify for me. Just what is the derivative of x cubed? X cubed here, it will be 3x squared. What is the derivative of negative 3x? It will be negative 3. You take 3 out, and what do you have? X to the power 1. X to the power 1. What is the derivative of x to the power 1? It's just 1. And here you have x cubed. Again, what is the derivative? It will be the same here, like 3 x squared minus 3 minus 3x. It will be minus 3 x cubed. Here, that is your n. I put n in front. I reduce 1, so that you have 2. And here you have x cubed minus 3x, right? That is called product rule, and no problem. That is correct. Some people say, oh, can I expand the bracket here? Can I expand it? I do the product here, and then I am going to take the derivative term by term. Yes, you can. It will be correct also. It will be correct, right? So now, today here, if you have y, the same problem here, exam number 2 here, exam number 2, I'm done here for this example here. I apply product rule. If you have x cubed minus 3x to the power 100, if you have to the power 100, then this bracket, it's a bracket multiplied by itself 100 times, then how many times you are going to apply product rule? How many times you are going to apply product rule? So what is the best here is, you could apply product rule, but it will be 100 times, or there are some software you can expand this bracket, and then you take the derivative term by term, but that is kind of time consuming and extra work. So we are looking for rules that is called the power rules. What is power rules? You have a bracket, that is power rules here. You have a bracket, that's a bracket to the power n. If you have a bracket, I call it f of x here, that is inside the bracket, that is you have a bracket to the power n. If I need to take the derivative of that, the derivative of this bracket to the power n, what is the derivative? It will be n And then here is your bracket. I reduce the bracket by 1. I reduce the bracket by 1. So that is your bracket to the power n. I reduce n minus 1, and then I have to take the derivative whatever inside the bracket. I have to take the derivative whatever inside the bracket. All right. So that is called power rule. So let me write this one. The derivative, just write it in word. The derivative whatever inside the bracket. The derivative whatever inside the bracket. Whatever inside the bracket. Then our inside the bracket, just write it for me. All right. So here, what is your f? What is your n? Oh, your n here, the exponent. You have a bracket to the power. Look at what I'm hearing here, or just it's good to hear yourself. Oh, a bracket to the power 100. If you have a bracket to the power something, then we use called power rule. Power rule because you have a bracket to the power something. All right. So here, what is your 100 here? That is your n. Here is the rule. What is inside the bracket? Inside the bracket, that is your f. Inside the bracket, what is your f? It will be x cubed minus 3x. So what is the rule? Y prime, according to this, the derivative of this, what is it? Will be n. What is your n? 100. I replace n by 100. And what is the bracket? The bracket x cubed minus 3x. And that is your f. That is your f. To the power n minus 1. What is your n minus 1? 100 minus 1. And f prime, that is the derivative whatever inside the bracket. The derivative whatever inside the bracket, and then we call it power rule. So what do you have? You have 100 here, x cubed minus 3x to the power 99. What is the derivative of x cubed minus 3x? It will be 3x squared minus 3. X cubed, 3x squared minus 3, and that is our power rules. Make it very easy, very simple for us to take a derivative like this instead of applying product rule for 100 times or more. Then it's good here to have a rule to apply. So that is your n. You have n here 100, and then I put n in front. I reduce n by 1, so you have 100 minus 1. 100 minus 1, that's what you have, which is 99. And then you take the derivative whatever inside the bracket, right? That is called power rules. So today here we are going to give power rules, and then next time maybe I give you the chain rule. So sometimes some textbook they call this one also a chain rule. They call it a chain rule. So let me give you another example here. If I have y equal 1 over x cubed minus 3x to the power 200 here, 200, right? And what is the question? Find y prime. All right, so read or find dy by dx is the same, or y prime or dy by dx, it will be the same. So now I have to apply the rule. How to apply this rule, guys? Look what you have here, guys. You have, read it loud, 1 divided by, you see, when you see divided by means quotient rule, and then divided by what? A bracket, x cubed minus 3x, a bracket to the power 200, a bracket to the, so that is the power rule. So now I said 1 divided by another bracket, so that is quotient rule, and then you have a bracket to the power 200, that is called power rule. So I have two rules here. I am going to use quotient rule and product rule. Quotient rule, product rule. Quotient rule because you said 1 divided by something. When you hear divided by, mean quotient rule. Then you have a bracket to the power 200. Then what is that? That is power rules. So now I ask myself here, because you have two rules I'm going to apply, can I simplify this so that instead of using two rules, maybe I use one rule? Yes. How to simplify this? Let us recall here. Recall. If you have 1 over a to the power n, 1 over a to the power n, how to take this one up? It will be a to the power minus n. It will be a to the power minus n. So I have your n here, the exponent n takes the opposite sign of that, it will be negative n. So here your y, it will be 1 over x cubed minus 3x to the power 200. So this one, it's like your a, that is your a here, that is my a to the power 200. So if that is your n 200, your a, what is inside a? X cubed minus 3x. If I take this one up, it will be x cubed minus 3x to the power negative 200, negative 200. So it will be x cubed minus 3x to the power negative 200, negative 200, right? So that is become easy now. So what did you have after I simplify? You have a bracket to the power negative 200. So that is only power rule because you have a bracket to the power something. So a bracket to the power something means I'm going to use power rules. So here, what is your n? Your n here is your power rules, f to the power n, a bracket. Your f here is a bracket to the power n. If you want, you can write it like this: f, the whole bracket here to the power n. I need to take the derivative of this. The derivative of this, it will be n, and then here is your bracket, your f. Whatever inside the bracket, it will be n minus 1, and then you have to multiply by the derivative whatever inside the bracket. The derivative whatever inside the bracket. So you have here y prime. What is your n? Your n here is 1. Oh, negative 200. So I have negative 200. And then what is the bracket? X cubed minus 3x. And then negative 200. That is your n minus 1. N minus 1. N minus 1. Right? That is your n minus 1. Your n here minus 1. Right? Minus 1. So you have to multiply by the derivative whatever inside the bracket. The derivative whatever inside the bracket, which is x cubed minus 3x prime. If I simplify this, you have negative 200 x cubed minus 3x, and this one I combine together, you have negative 201. Negative 201. And what is the derivative of x cubed? 3x squared. What is the derivative of negative 3x? You have negative 3. Alright, you have negative 3, and that is our rules here for this. So I go for a difficult example here where you have a sheet in your your model there about the chain rule, and then that is the one I'm going to solve now. So if you have a problem like this, number 1d, what is that? You have s of x equal square root of x squared minus 3x. Square root of x squared minus 3x. Then you know this square root means that's called radical. In order to avoid radical here, try to switch from radical to exponent. How to switch from radical to exponent? Then you can write this as x squared minus 3x to the power what? The whole thing to the power 1 over 2. If you have a square root, I can write that to the power 1 over 2. Now, what is your s of x? S of x is a bracket to the power 1 over 2. You have a bracket to the power 1 over 2 means the power rules. So what is your n here? 1 over 2. So what is your s? Your s is a function in x. S prime, it will be 1 over 2. And when I take the derivative of this, it will be x squared. That is the bracket. I reduce n, that is your n here, minus 1, n minus 1. And I have to multiply the whole thing by the derivative whatever inside the bracket. The derivative whatever inside the bracket. Right? So if I simplify this, you get 1 over 2. X squared minus 3x. 1 over 2 minus 1, you can write decimal as negative 0.5. You can use technology, 1 over 2 minus 1, you get negative 0.5. And now that is prime here. I need to take the derivative whatever inside the bracket, which is derivative x squared is what? Is 2x. The derivative of negative 3x, it will be negative 3, right? X squared, 2x. Negative 3, that's a constant out. What do you have x? What is the derivative of x with respect to x? It will be 1, just 1. So that is my derivative here. You leave it as it is, no simplify. That is your s prime of x. S prime of x. Okay, so we solve this one here. I'm going to solve in the sheet here that I'm talking about another example here where you have your f of x, big F of x equal 2x squared minus 3, 1 minus x cubed. I need to take the whole thing to the power 6. The whole thing to the power 6, right? So what do you have here, guys? What I have, you have a bracket. You have a bracket to the power 6. A bracket to the power 6. That is your n. So that is power rule because you have a bracket to the power 6. But what is inside the bracket? You have a fraction. You have a fraction. Then you have to use quotient rule. I cannot avoid. Here I'm going to use both power rule and quotient rule. Let me show you f prime of x. That is your bracket here. What is your n? Your n is what? 6. So I put 6 in front. Here is your bracket. You copy as it is. 2x squared minus 3, 1 minus x cubed, and n minus 1. N minus 1. And then I have to multiply by the derivative whatever inside the bracket. The derivative whatever inside the bracket. Right? So this one here, that is your f. Whatever inside the bracket, we call it f. The exponent here is n, that is your n, right, which is 6. So I put n minus 1, that is your f, and then f prime, that is your f prime, which is that whatever inside the bracket, Now I have not finished yet, because this one I have to take the derivative of 2x squared minus 3 over 1 minus x cubed prime. I need to take the derivative of this, right? I need to take the derivative of this one here. I can do it separate here. What is the derivative? That is quotient rule. If you have f divided by g prime, it will be g squared g f prime minus f g prime. So that is f over g. It will be f over g prime. It will be g squared g f prime minus f g prime. So now what you have? You have 1 minus x cubed square, 1 minus x cubed square, and g, what is your g? 1 minus x cubed, and then f prime here. What is f prime? That is what you have here up, right? F prime, which is 2x squared minus 3 prime, then minus in the middle, you have minus sign here. F, what is your f? Whatever I have up, which is 2x squared minus 3. G prime, what is g prime? It will be 1 minus x cubed prime. If I simplify this, what is the derivative of 1 minus x cubed, right? 2x squared. What is the derivative of 2x squared? Yeah, 4x, very good. What is the derivative of negative 3? Negative 3, guys. What is the derivative of negative 3? It's a constant. What is the derivative of any constant? Should be 0. The derivative of any constant should be 0. Minus 2x squared minus 3. Now, what is the derivative of 1? The derivative of 1 is 0. It's a constant. Minus x cubed. Minus x cubed. What is x cubed? It will be 3x squared. Derivative of x cubed, which is negative 3, because negative sign in the middle, you have 3x squared. And the whole thing divided by 1x cubed square, 1x cubed square, right? So that is, I go back to the formula here. Just take whatever you have here, just copy up. You have to go here and just replace this one here, the circle here, replace it. So your big F, look what you have, your f prime 6, a bracket to the power 6 minus 1, which is 5, and the derivative that you have. So if I write this, big F prime of x, it will be 6, the bracket, which is, just try to copy the bracket, 2x squared minus 3, right? 1 minus x cubed. The whole thing here to the power 5, and then I copy the derivative here. Just copy the derivative whatever you have up, then you are done. What is the derivative? 1 minus x cubed, right? 4x minus 2x squared. You don't need to simplify, no simplify here. So x squared, the whole thing divided by 1 minus x cubed over square. So I leave it like this. Okay, so how did I do this? Again, here you have for this example here, you have a bracket. You don't care what is inside the bracket. You have a bracket to the power 6. So what is your n? 6. So I put 6 in front, that is my n, and then here is the bracket, n minus 1, and then you have to multiply the derivative whatever inside the bracket, which is 2x squared minus. So what is in the derivative inside the bracket? It turned out it's a fraction. Then you must apply quotient rule. Here is your quotient rule, g squared g f prime minus f g prime. I square g, which is 1 minus x cubed, square it, and g, that is your g, right? G f prime, look what you have, f prime minus f g prime. So what is prime here? 2x squared, which is 4x. What is the derivative of negative 3? That's a constant, 0. And here you have 1 minus x cubed. What is the derivative of 1? 0, because it's a constant. What is the derivative of negative x cubed? You have minus 3x squared. Minus 3x squared, just that is 3 here. Just you copy. So you have minus 3x squared, and then you copy as it is. That is our, we call it here our Bauer rules. Okay, so I have to give you here another one, number 3. What is that? You have f of x given 5 over 25 square root of 25 minus x squared. Right? What is the question here? The question here is, you have two questions. The first one, find the domain. What is the domain of your f of x? Right? What is the domain of f of x? B, I need to get the slope of f at x equal 4. The slope of f at x equal 4, right? So now, before I take the derivative, the slope, what is the slope here, guys? The slope here, the slope is nothing. The slope of your f is nothing but your derivative at 4. Your derivative at 4, that gives you the slope of your f. Give you the slope of your f, or give you the slope of the tangent line, the slope of the tangent line. That is equal 4. So now what is the domain? The domain here is you have 5 over square root of 25 minus x squared, right? So here, what is the domain? We cannot divide by 0, right? We cannot divide by 0. Here I have to be careful because you have a square root. Whenever you have a square root, just let me the domain here of 5, f of x equal 5, right? And here divided by 25 minus x squared. First of all, we cannot divide by 0, right? Cannot divide by 0. So here we cannot divide by 0, which means you cannot have 25 minus x squared can be 0, right? 25 cannot be 0. So which means your 25 cannot be x squared, right? Or if you want, so what is your x? Plus or minus 5. If I solve this, it will be x cannot be plus or minus 5. Or just you can write 25 minus x equals 0, right? And then you factor out, so you have 5 minus x, and here you have 5 plus x equals 0. Then your x 0 product, 5 minus x equals 0, or 5 plus x equals 0. So you could have x equal 5, or x can plus or minus 5. So which means the domain should be all real number except plus or minus 5. But here, if you have, this one is correct. If I have, say, what is the problem here? If you have 5, if I give you f of x equal 5 over 25 minus x squared, then you can tell me, oh, the domain of this one is all real numbers except all real numbers. Let me write it here, all real number except here plus or minus 5, except plus or minus 5, or real number except that is okay. But here, because you have a square root, whenever you have a square root, then whatever you have under a square root must be greater than or equal 0, right? Greater than or equal 0, right? Here, greater than or equal 0, because the square root of 0 give you 0 is okay. Square root of positive number is okay. A square root of negative number, you have error. You can use technology. Square root of negative 1, you will have error. So whatever you have under a square root cannot be negative. It should be positive or greater than 0. But here it could be 0 and greater. But here, because you have dividing 5 over 25 minus x squared, right? So that is your f of x. I cannot have 0 here. So whatever I have under square root must be greater than 0, cannot be 0 because you have a fraction, right? So now, how to solve it? That is called inequality. I require 25 minus x squared should be greater than 0. 25 minus x squared should be greater than 0. So how you have this one here, 25 minus x squared greater than 0? How to solve this inequality? That is called quadratic inequality. Let me solve it for you here. Quadratic inequality. How to solve quadratic inequality? Any inequality, that's called inequality. Inequality here is inequality. How to solve inequality? 2 steps. Step number 1, you make it equal 0. Step number 1, you make it equal 0. So you have step number 1, 25 minus x squared equals 0. That is we solve that up. You have plus or minus 5. Plus or minus 5. And then step 2, those two numbers, plus or minus 5, dividing the whole thing to two numbers, to sub-interval. That is the entire real line. So you have minus 5, you have here plus 5. So those two numbers dividing the whole thing to 3 intervals. So you have 5 plus infinity. And here you have minus 5 to 5. And then you have minus infinity to minus 5. So I have 3 intervals, from 5 to plus infinity, from minus 5 to 5, and from minus infinity to negative 5. So these two numbers, which is plus or minus 5, dividing the whole entire real line to 3 sub-intervals, from minus infinity to minus 5, from minus 5 to plus 5, and from 5 to plus. So which one is, that is our inequality. I'm going to take, it's called test problem. So here, for example, x equals 6 as a test. Take any point from this interval. If I put it here, 25 minus 6, what did you get? if you get 25 minus 6, which is 36, what did you get? You get negative number, right? So you get negative what? Negative 11. So it's a negative number. So here I require must be positive. So that is not a solution. This one is not a solution. So now I take negative 5 to 5. What is the simplest number from negative 5 to 5? Take x equals 0. If I take x equals 0 here, you get 25. Is 25 greater than 0? Yes. So that is the solution. Yes, that is our solution. What is the last one? I take x equals, say, negative 6 here, negative 6. If I take x equals negative 6, I put it there. You get also 25 minus 36, which is less than 0. So that is not a solution because you require our inequality must be greater than 0. So what did you get here? Negative 5. So what is my interval? Negative 5 and 5. That is my domain. That is our domain. So one is going to ask, can I put here, it's open interval, can I include closed interval? I say no, we cannot include closed interval. Why? Because if you have plus 5 or minus 5, if you include 5 and negative 5, then what you have here, look what you have, that's a fraction here, right? Then you are going to divide by 0. If x equals 5, you get 25 minus 5, which is 5 over 0, and you have error when I use technology. So plus or minus 5, they are not in the domain. So what is my domain? My domain for this problem, minus 5 to 5. Minus 5 to 5. That is, it's a difficult one, but is okay. At least I solve it. So now I need to get the derivative, right? What is the derivative of f of x? Equal to 5 square root of 25 minus x squared. So simplify this. It's 5 divided by square root means it's, you have divided by mean quotient rule. You have this one square root. I could write it as 5 over 25 minus x squared to the power what? 1 over 2. You take whatever you have under square root, right? And then that is to the power 1 over 2, to the power 1 over 2. So what do you have? You have 5, 25 minus x squared. So now again, as I did before, that's divided, 5 divided by this. And here it's a bracket to the power 1 over 2. That is the power rule, and you have divided me in quotient rule. Avoid quotient rule here by taking this one here up. Your constant here, 5, you leave it as it is. Only take whatever you have down here. This one, it will be 25 minus x squared to the power what? Negative 1 over 2. Negative 1 over 2. Right? So now I can use Bauer rule because you have a bracket to the power negative 1 over 2. So now what is the derivative of this? The derivative of this, it will be 25 minus x squared to the power negative 1 over 2. I need to take the derivative of the whole thing, right? 5 here, it's a constant. Means you can grab it outside of your derivative. That's what is inside 25 minus x squared, negative 1 over 2. You have prime. So 5, you can grab it outside of your derivative because it's a constant multiply, right? You can grab it out. So now that is, what is your n? That is Bauer rule here. What is your n? Your n here is negative 1 over 2. Negative 1 over 2, that is my n. Here is your bracket. Your bracket here, 25. N minus 1. So you have negative 1 over 2 minus 1. And you have to multiply the derivative whatever inside the bracket, which is 25 minus x squared prime. 25 minus x squared prime. So what do you have? You have 5 multiplied by negative 1 over 2. You have negative 5 over 2. And here 25 minus x squared to the power what? Negative 1.5. Right? And here, what is the derivative of 25? The derivative of 25 is 0. It's because it's a constant. What is the derivative of negative x squared? You have negative 2x. Again, the derivative of 25. What is 25? It's a constant. What is the derivative of any constant? Should be 0. Minus x squared. What is the derivative of x squared? You will be negative 2x. Right? So that is your f prime, yes. But the question here is, they ask you to find the slope of your f when x equal 4. So what is your slope of your f? That is your f prime. That is your slope here at 4. So go ahead and replace x by 4. Then you are done. Negative 5 over 2. 25 minus, what is 4? You have 16. Negative 1.5. And negative 2x. What is 2x? You have negative 8. I replace x by 4. So negative 2 multiplied by 4, you get negative 8. If I simplify this, what do you have? Look what you have. Negative 5 multiplied by negative 8. What do you have? You get 40. Plus 40 divided by 2. And here you have 9 to the power negative 1.5. If I use technology for this, what do you have? You have 40 divided by 2, which is 20 here, 20. And this one, you could write, you can use technology, or you can write it like this. 9 here, it could be 3 to the power 2, and here negative 1.5, right? So you get 20 and 3. How many exponents you have here? 2 exponents. So you have 2 multiplied by negative 1.5, which is negative 3. So you can use technology and decimal here. Negative 3 here, it will be 1 over 27. This one, 1 over 27, or you just use the technology. Excuse me. Use technology, and then when you use technology, you get 20 over 27. And that is our slope. That is our slope. If I ask the same question, what is the slope of the tangent line? Here is your slope of your tangent line, which is 20 over 27. Okay, guys, so that is that one problem. So now I have to give you something before you go, which is, it's called composition of functions. So that is, I have to give it to you, how to take the derivative of this. All right, so what is composition of functions? You know, if you have, we write it, here is the definition F, we write a small circle. This one means composite of your G for your X. Here is, you write it F G of X, like this, F of G of X. So let me give you an example here to have feeling. So if I have F of X equal X square, all right, and what is your F of G of X? What is your F of G? Then F of G means you replace X by G. You just replace X by G. Here is your X. Here is your X. Inside this circle, that is your X. Take X out and put G. Then what you have? You have G square. If I replace X by G, then you have G square. So now, if I tell you F of X, G, I tell you where G equal X cubed. G equal X cubed. So I give you F of X, and then what is F of G of X? Oh, G square. How did I get G square? Just take X out, replace it by G, get G square. But if I tell you G equal X cubed, then how to get F of G of X? F of G of X here is, F is a function in G of X. Means you replace G by what? By X cubed. You replace G by X cubed. Here is your G, which is X cubed. That is inside the bracket. The whole thing to the power what? To the power 2. To the whole thing to the power 2. So that is your circle here. Inside the circle here, that is your G. Just take G out. Take G out and put it, replace that by X cubed. Replace that by X cubed. Then what did you have? You have X to the power 6. X to the power 6, right? So you have 2 exponent, 2 multiplied by 3, get X to the power 6. So now, if I give you F of X equal whatever, and I give you G like this, then if I ask you how to find F of G of X, then you take first, step number 1, replace X by G, replace X by G. That's what I did. And then take G, replace it by whatever given here, then you are done. That is called composite function. So our goal for question number 4, how to get the derivative of this composite function. For example, here, question number 4, that is in the sheet, you have F of X is given here, F of X equal X to the power 1 over 2 plus 2X minus 1. What is your G of X? Your G of X equal 18 X minus 2 to the power negative 1. All right, so what is the question here? I have 2 questions. Find A, what is your F of G of X? 2, what is your F prime of G of X? And just take the derivative. So step number 1, let us here get the derivative of F of G of X. What is the derivative of F of G of X? All right, so that is, let me call this equation 1 and 2. So here, as I told you, step number 1, just take, here is your X. Where is your X? I put circle. Look what you have. I put circle around X. Or here X circle. You have the constant, I leave the constant. Then I'm going inside the circle here, just replace the circle here, X by G. That is step number 1. So F of G, just write it here, F of G, right? Just F of G, it will be G square. Just replace X by G. Take X out and put G. So what do you have? You have G square plus constant 2. What is that? G to the power minus 1. Right? That is step number 1. Step number 1, what I did, step number 1, just replace x by g, replace x by g. That is step number 1. Step number 2, I'm going to, g here is given, equation number 2 here is given, then I'm going to take g out, and then I replace it by 18 over x minus 2. Take g out. Again, how you replace something, you just both circle here, both circle here. So that is inside the circle here, I could, what you have inside the circle here, that is your circle here, the circle here to the power 2 plus 2, and circle here minus 1. So inside the circle around g here, I can replace it by what is given here, 18 multiplied by x minus 2 to the power negative 1. So I write here 18 x minus 2 to the power negative 1. Here 18 x minus 2 to the power negative 1, right? So that is our f of g of x here, right? So what I did, step number 1, I replace x by g. Step number 2, I put around g circle, and then I took g out, and then I put it by what is given in equation 2. What is equation 2? 18 x minus 2 to the power negative 1. So if I need to simplify this. In order to simplify this, let me recall for you, if you have a to the power b to the power n, can I write this as a to the power n, b to the power n? Yes, you can. If you have a multiplied by b, or a divided by b, yes, you can say a to the power n over b to the power n. But if you have in the middle plus or minus, then you cannot say this one equal to an plus or minus bn. You cannot say no, they are not the same. But here, if you have a product, yes, it's the same. If you have division, it's okay, but this one is not okay. All right, so now I return back here. What is your, you have a product, 18 multiplied by x minus 2 to the power what? To the power negative 1. But what you have is given here, 18 x minus 2 to the power 1, negative 1. So that is your a, and that is my b, a, b. The whole thing to the power what? To the power 2. That is your n. Look what you have, a multiplied by b. So what is your a? I'm just write 18, that is your a. What is your b? X minus 2 to the power negative 1. X to the minus 2 to the power negative 1, that is your b. So if what is the n? Your n is 2. So if I simplify this, if I have 18 to the power what? 2, right? And then you have the second one, x minus 2 to the power here negative 1 to the whole thing, that is your b to the power 2, right? So you have a, that is your a, 18 to the power 2, and b x minus 2 to the power negative 1, the whole thing, that is b to the power 2. What is the second term? The second term here, you have 2 outside. So I leave 2 here outside as it is. And now what you have 18 multiplied by x minus 2 to the power negative 1, the whole thing to the power negative 1. That is new n here, that is new n, negative 1. So you have 18, your a here is 18 to the power, what is negative 1? So you have 18, I should write 18 to the power negative 1. And the second one, x minus 2 to the power negative 1, the whole thing negative 1. So that is, you have 18, look what you have, 18 here, that is your a, x minus 2 to the power negative 1, that is your b, right? So if you confuse, take a equal 18, take b equal x minus 2 to the power negative 1, x minus 2 to the power negative 1. So that is your a and b for this rule. But here your n is negative 1. Your n here for the first term is 2, and the term, your n in the second term is negative 1. So if I simplify this, you have 18 square. Can use technology or can leave it like this. How many exponents you have here, guys? You have 2 exponents. What is the 2 exponent? You get negative 2. Negative 1 multiplied by 2, you get negative 2. Plus 2, 18 to the power negative 1. You could write 18 to the power negative 1 like this. And here, how many exponents you have? 2 exponents. Negative 1 was negative 1. So you have x minus 2 plus 1. Negative 1 multiplied by negative 1, you get plus 1. So is what you have here, that is your f of g of x. Right? How to simplify? Some people say, can I simplify? Yes, you can. If you can use technology for this. You can write whatever the number, or you just leave it like this. It's a constant, so I'm not worried about it. Right? And this one, I could write it as 2 over 18. What is 18? 18 to the power negative 1, I could write it as 1 over 18, x minus 2. 2 over 18 here, you could write it as 1 over 9. 1 over 9. 1 over 9. So now what is the question B? What is the derivative of this composite? It's called composite functions here. Composite function here. I need to take the derivative of this. So what do you have in the middle? You have in the middle plus, which means I have to take the derivative term by term. So you have 18 x minus 2 minus 2. I have to take the derivative of the first term like this. That is 18 square here, right? And plus here, what do you have? 2 over 18, we have 1 over 9. And here x minus 2, right? X minus 2, I have to take the derivative of the whole thing. Because in the middle you have plus, means you take the derivative of the first term plus the derivative of second term. And then I have to take the derivative 18 square. 18 square, that's a constant. I can grab it outside of my derivative. What is inside x minus 2? It is about negative 2 prime. Right? It's a constant. I grab it outside of my derivative. Here 1 over 9, I can grab it our outside also, but you have inside x minus 2 prime. So now that is your f of g of x prime, the whole thing. So now how to take the derivative of this one? Look what you have, guys. 18 square. What is the derivative of x minus 2? That is power rule. A bracket to the power n. A bracket to the power n. What is your n? Negative 2. What is your bracket? X minus 2, n minus 1. It will be n minus 1. What is your n? Negative 2, n minus 1. And do not forget to multiply by the derivative, whatever inside the bracket. The derivative, whatever inside the bracket. And now you have 1 over 9. What is the derivative of x? What is the derivative of x? It's 1. Very good. The derivative of x is 1. What is the derivative of negative 2? Negative 2 here is 0. Why? Because it's a constant. Negative 2 is a constant, 0, so you get 1 over 9. If I simplify this, you have 18 square, negative 2, right? What is the derivative of x? 1. What is the derivative of negative 2? 0, because it's a constant, so this one give you 1. Negative 2, and here x minus 2 to the power negative 3. Here, negative 2 is negative 1, you get negative 3. And here what you have 1 over 9, right? So just leave it like this, no simplify more is okay. So that is your derivative of your composite, okay guys, 1 over 9. So that is, I want you to go through all of this to see how far, if it's clear. If it's not clear, please come and ask. So that is, it will be contact me here or just come to my office to ask about this. So let me summarize what I did for this problem. What I did for this problem is called composite functions. How to handle composite function. Step number 1, you have to find f of g. So you take x out, replace it by g. Step number 1, you replace x by g. Around x, you put circle. Around x here, as you can see, circle. And then around this circle, what you have, you replace x by g. Here, that is red here, as you can see, circle around x. Then you take x out, and then you replace it by g. Replace x by g. That's what I did here. I replace x by g. You get g square instead of x square. You have g square because I took x and I replace it by g. And here 2. That's 2. I leave it 2 as it is. Gx here, what will be g to the power negative 1. And then that is step number 1. I replace g. Then what is g? G is given here, equation number 2. Then I put a circle again around g, as you see here, circle again around g. And then I took g out. I replace it by what is given, which is 18 x minus 2 to the power what? Negative 1. And here you have 2, it's a constant. Then g, that is the circle here, 18 x minus 2 to the power negative 1. So now that is here is the rule I'm using. A multiplied by b, it will be a to the power n, b to the power m. The first one, a is 18. What is your b? X minus 2 to the power negative 1. That is what I wrote here. And then the whole thing to the power n, which is 2. So what I did, you take 18, look what you have, 18 to the power 2 here, multiply by x minus 2 to the power negative 1, the whole thing to the power 2. How many exponents you have here? 2. Negative 1 multiplied by 2, you get negative 2. 18 squared, that's a constant. You can use technology, no worry about it. So negative 1 multiplied by 2, you get negative 2. And 18 squared. Now, for the second term, you have 18 to the power what? Negative 1. So I write here 18 to the power negative 1. And the second term, b, x minus 2 to the power negative 1. The whole thing to the power negative 1, you have 2 negative Look what you have here, -1 here, -1 here, and you have -1 here too. So negative times negative, what did you get? You get +1. So 18 to the power -1, I can write it as 1 over 18. 18 to the power -1, I can write it as 1 over 18. 2 cancel with 18, you get 1 over 9. 1 over 9, so I wrote here 1 over 9. And here, now I'm going to take the derivative, that's question B. Question B, you go ahead and take the derivative, and I need to get the prime here. So 18, that's a constant. Here, what you have in the middle plus, you take the derivative of the first term plus the derivative of second term. Here is prime, the first term, and the derivative of second term. 18 square, it's a constant, I can grab it outside. And then I have -2 here. And 1 over 9, I can grab it outside because it's a constant. And then what you have left, derivative of x minus 2. What is the derivative of x minus 2? Derivative of x is 1. What is the derivative of -2? 0, because it's a constant. And here you have a bracket to the power n. I'm going to use Power rule. N, I put n in front, and then I reduce n by 1, n minus 1. And I have to take the derivative whatever inside the bracket. The derivative whatever inside the bracket, which is x minus 2, derivative of x1, -2 is 0. Then what you have, -2 is -1, you get -3, right? And here 1 over 9. Then I leave it like this, you are done. Okay, all right, I will stop here, guys. I will continue next time how to take chain rule, how to take the chain rule, and then I will say, okay, I will stop here. Thank you.